What do they want us to do with this? Can't we just like anti-differentiate and not worry about it? I mean, yeah, I'm sure we could write this as a line and interpret it in terms of like rectangles and triangles and stuff. But it's also easy to just go 2x squared over 2 minus 12x and evaluate it. Okay, we got an antiderivative. Let's substitute 7 and 2 in. So we need 7 squared minus 12 times 7. So that's going to be our first bit. And then we'll subtract 2 squared minus 12 times 2. An antiderivative, that is correct, yes. A single one. We just need a singular one. And the antiderivative will do. So we need 49 minus 12 times 7. That's going to be negative 35. And then we need 4 take away 12 times 2, which is negative 20. So we're going to be adding 20. So it feels like this should be negative 15. So from 2 to 4 of x squared plus 4x minus 3. Let's see if I can remember how to do this. We need to calculate our delta x, which should be 4 take away 2 over n, and that's going to be 2 over n. And we know that our f of x is equal to x squared plus 4x minus 3. So f at, oh gosh, we have to start at 2, right? We have to go 2 plus I delta x. Is that how this works? But like, check this out. Like, this is crazy. Like, this is 4 plus 2 times this, which is 2 times, so it's 2 times 2 times 2, so it's going to be 8i over n plus 4i squared over n squared plus plus 8 plus 8i over n minus 3. Like, this is going to be the function that we need to work with at any given spot, because what we're doing is we're thinking about this as a limit as the number of rectangles gets really, really big. And I don't particularly care if we start at 1 or 0. I don't think it really matters. I guess if we start at 1, that would be the right endpoints. Do you even remember the sum of I squared? I don't know. Use the lim infinity with the lim sup lim inf. Oh my gosh, like actual true Riemann integration? Man, I like reviewed that the other day and I was like, oh, this is how integration works. That's actually really fucking cool. But yeah, so we need to take our f at xi and multiply it by delta x. All right, so we need our f at xi times delta x. That's what our limit looks like. Yeah, I squared equals negative 1. I love it. That's my favorite relationship. So it's going to be this times fucking 2 over n. So it's going to be, let's see, we can put the 2 over n here because it shouldn't be affected by the sum that we're working with. And we have 4 take away 3, so that's going to be 1. So we can simplify that a little bit. That's as good as it gets. Oh, is this really an 8? So we could do 1 plus 8, which is 9. So we could maybe simplify this a touch more. So let's write this as 9. That'll take care of that. Then we have 16i over n, and then the 4i squared over n squared. And that's what we need here. So 9 plus 16i on n plus 4i squared on n. So we're going to zoom in and start focusing on this, what I think is the limit that we need. So 2 over n, we need to distribute our sum to all of the pieces. So we have the sum of 9 plus 16 over n the sum of I plus 4 over n the sum of I squared. And yeah, now do I remember what the sum of I squared is? Yikes. So 2 over n. The sum of 9 is just going to be 9n, right? Thank you for the lurk, Enigma. We'll chat with you soon. For sum of I get 16n. This is n plus 1 over 2. And then this is going to be, oh gosh, n. No, what is this one? Oh, I always forget I squared. It's over 6. N plus 1, 2n plus 1. How'd I do? Did I get it, chat? Did we get it? Can I QED myself? Did I get it? Is it n plus 1, 2n plus 1? No, it's n plus 1, n plus 2. What? Hi, Nylon. What was the 4i squared over n? Oh, that, yeah, I got it. So I'll zoom out a little bit so you can kind of see. So I was trying to clean up this f of xi bit. So I tried to kind of like expand this squared bit. That gave me these 3 terms, and I distributed this out to give me these 2 terms. And then I wanted to kind of combine some like terms, basically. So I noticed that I had there was a 4, an 8, and a 3. And then there were 2 8i over n's to give me 16i over n. And then there was this leftover 4i squared over n squared. So that 4i squared over n squared comes from squaring this piece right here. I very much could have copied that down incorrectly. Yep, so you are correct. So I need an n squared here, I think is what you're saying. So let's expand through, let's start canceling some stuff. So we can cancel like this. We can cancel 1 copy here. We can maybe get rid of this factor of 2, and there's a factor of 2 here as well. So we're working with a limit as n gets big. This is going to be 18. And then we'll have plus. Oh, I have an n here, right? So this should be 8 n plus 1 over. This should be 16 n plus 1 over n. And then here we should have 2 times 2, which is 4 n plus 1, 2n plus 1 over n squared, 3n squared. So we have 18 plus the limit as n gets big of 16n plus 16 over n. And then we'll look at the limit as n gets really big over whatever this expansion is. I really just care about the dominant term here. So let's just grab the dominant term, which is going to be 4n 2n. That's going to be the highest power that I need. And the same thing here. I can kind of get rid of this 16. It's not going to play much of a factor in our limit as we're getting really, really big. So we should be getting something like 18 plus 16 plus 8/3? 8 over 3? Does that seem right? Oh my gosh, up to I to the power of 5? Oh my gosh, that would be so painful. All right, this should come out to be a reasonable number. So 18 plus 16 plus 8/3? 110 over 3. All right, so we've expanded. Let's go ahead and find an antiderivative. We'll go x cubed over 3. We'll do a 2x squared over 2, and let's do a 15x And we need to evaluate this antiderivative with an upper bound of 3 and a lower bound of -2. So let's get rid of these 2's. And we have something like 3 cubed. So 3 cubed is 27, right? 3 times 3 times 3. So 27 over 3 is 9. So 27 over 3, we have an x squared. So that's 9. And then a 15 times 3, which is 45. And we need to subtract the lower bound. So -2 cubed, that's going to be -8/3. -2 squared is 4. And then 15 times -2 should be +30. So we're looking at something like this. I'm just going to pop this into my calculator. Let's go 9 plus 9 minus 45 plus 8/3 minus 4 minus 30. So it looks like -175 over 3. Okay, chat. If f of x is equal to the integral from x to 19 of t to the 6 dt, then what's f prime? The fundamental theorem of calculus would exactly do what Splooey is thinking, which is we're going to alter the bounds from x and 19. We're going to swap these to 19 at the bottom, x at the top, by making it a subtraction. Absolutely, that is what we want to do. And then once we have that, then we can just take the derivative, and it should be -x to the 6. Boom! Nicely done. So if we take the derivative of this, we should get x cubed, and then the derivative evaluated at 5 should be 5 times 5 times 5, which is 125. I'd probably use chain rule. I'd probably say f at u is equal to -2u t squared dt, where u is equal to x cubed. And we know that if I want to find the derivative of f with respect to x, we could just take the derivative of f with respect to u, and then multiply that by the derivative of u with respect to x. So this one can be found using the FTC, and then this one we can find just by finding du dx. So this one we can find, this is 3x squared. Now, for the FTC part, that's just going to be u squared, I think, by the look of it, right? So our f prime with respect to x should be u squared times 3x squared. But we know that u is equal to x cubed. So let's put x cubed back in. And what do we get? This is x to the 6 times 3x squared. Is this 3x to the 8? Is that what our derivative is going to look like? 3x to the 8? Use part 1 of the fundamental theorem of calculus to find the derivative. This should be 1/4 x squared minus 1 all to the power of 8. Bam. Done and dusted.